So now that we know what a conversion factor is, how to recognize the standard equality form versus the fractional form, and how to write both, we now can actually get into using conversion factors to change units. So what I have here is a chart of some conversion factors. Notice that it's in its equality form, going from metric and into standard units. So we have some standard units here for length, weight, and capacity. And then we have length, mass, and capacity in the metric. Okay, so what we're going to do is we're going to use these equalities to change units from one to another. Okay, and what we're going to do is we are going to do this by using its fractional form. When you do a conversion factor, you are going to want to set it up so that you cancel units. So how do we cancel units? Well, we're going to cancel units. So let's go back to our simple little example here. One circle equaled 2 squares, and 1 square equaled 3 hearts. Okay, so we have this simple picture here. All right, so let's say I wanted to figure out if I had 3 circles, how many hearts that would be. Okay, so we've got to do some conversions. All right, so what you do is this is called your given information. It's given to you in the problem. So that's always your starting point. Next, you're going to set up fractions to cancel the units. All right, so when we set this up, you're going to create fractions. So whatever is on the bottom of a fraction, so if I set this fraction up, because we already know that if I took 1 over 2, or I could do 2 over the 1, okay? You want to set up your fraction so that whatever the unit is on the top, it is the fraction set up to have that unit on the bottom, because what you're technically doing is when you divide by a unit, so if I had 1 centimeter divided by 1 centimeter, centimeters cancel and you're left with just the whole number 1. Okay, so whenever you divide by a specific unit, it cancels out that unit. So that's why we always set up our fraction for the unit that we want to get rid of to be on the bottom. So in this case, I would use the fractional form in that orientation, because the circle's on the bottom. And when I write it like that, mathematically what happens, all right, is my circles cancel out. So I'm going to go here in a different color. Let's do blue here, purple. All right, my circles cancel out. So what it leaves me in is the unit, the square, okay? So I want to figure out how many hearts, if I had 3 circles, how many hearts that would equal. So what we've got to do is we got to finish, because right now, because I got rid of the circles, I'm left in the square, and we want to get into the heart. So this equality is going to come into play, and remember we could write it 1 square over 3 hearts, or I could write it in its inverse form, 3 hearts over 1 square. So I want to use the fraction form that has the square on the bottom. So that's going to be this guy here. And when I put it in my problem, I now can get rid of the square. And what unit am I left in? Well, it's the only unit not crossed out is the heart. And that's what we were trying to get to. All right, so what I always do when I set up dimensional analysis, I set it up and I go ahead and get all of my units canceled and make sure I'm ending up in the right unit. If the unit that the problem is asking for is the lone man standing, then you have set your problem up correctly. So I always cancel out my units first and see what lone unit is left, and if it's matching what it's supposed to be, I know everything else is set up right. So the last thing we would do to solve this problem is to carry out the math functions with the numbers. So when you move across, remember this is just like multiplying fractions. You multiply everything across and then divide by what's on the bottom, okay? So I would take, so what this is saying 3 times 2 times 3 over 1 times 1. That's what that is saying. So I can go ahead and carry out the math. So 3 times 2 is 6, right? And then 3 times 3 is 9. So I am left with 9 over, and then 1 times 1 is 1. So I'm left with the number 9. So 9 hearts. So 3 circles is the same as 9 hearts. Okay? So that's what we're doing here. That is what dimensional analysis is. And the reason I wanted to start out with something basic with just shapes is because sometimes when you start throwing in bigger numbers or actual units, people seem to get kind of confused. So let's look at our units here, our first problem. So we have 4,000 pounds, and we want to change that into tons. All right, so we're going to look here at our weight equalities and see what we can come up with. So here you can see I've got pounds and I'm tons. All right, so we're going to use pounds and tons. So I'm going to use these two equalities. All right, so I've got pounds. So we're starting with the given. So the given is the numbers that are given to you. That's my given here. And my known is what it's asking me to get into, or my unknown, sorry. My unknown is tons. That's what my end units should equal out to. So when I cancel out all the units, my lone surviving unit should be in the ton if I set it up right. All right, so I'm going to go ahead and I'm going to write my known, 40,000 pounds. Okay, and now we're going to start crossing out. So I want pounds on the bottom because pounds is on the top right there. I want pounds to be down here. Okay, so if I look up here, here is my pounds equality that I'm going to set up. So I'm going to put the 1 on the bottom because that's pounds, and then 16 ounces on the bottom. So what this does is it gets rid of pounds. Okay, so now I'm left in ounces. So now we need ounces on the bottom. And so, well, look at me. I didn't even need both of them. Already messing up here. Let's try this again. Sorry, guys. I didn't even read that equality right. Okay. So actually, we only have to use one equality. Look at me looking over that. There it is. 2,000 pounds equals 1 ton. So I want the pounds on the bottom. Still setting it up right. Okay, and then the 1 ton on top. So this is only a one-stepper because once I cross out my units, my lone standing is the ton, and that's what I was asked for here. All right, so I'm going to take 40,000. I'm going to multiply it so we can simplify this out. So 40,000 times 1 divided by 2,000. All right, so what is that going to leave me? With 20,000 tons. So 40,000 pounds is the same as 20,000 tons. All right, let's look at the next one. All right, so our next one is we're going to go from yards to feet. Okay, luckily for right here, yards and feet are all in the same one, so I don't need to use multiple equalities. So I write down my known. My known is 789 yards, and I'm going to convert it into feet. So because yards is on top, when I set up my fractional form, I want this equality to have the yards on the bottom. So that's going to be the 1 yards. All right, and then 3 feet on the top. So I'm going to go through and I'm going to check to make sure I set it up right. So yards is going to be crossed out. It's going to cancel. And my lone surviving is going to be feet. And if I look at the problem, that is indeed what they wanted me to have it in. So now I can go ahead and simplify. So I'm going to do 789 times 3 divided by 1. So that is going to give me 789 times 3, 2,000, and 2,367. Okay, 2,367 would be my final answer.